Okay, let's try to build our own custom Plutus validator and execute it on chain using Aiken, the Cardano CLI, and the meter. You don't need to use the meter for this. You can run everything locally, but you'll need to install the Cardano node connected to a testnet. You will need the Cardano CLI, the Aiken toolchain, and Jupyter notebooks. Now, the meter provides you with all of this out of the box. You just need to go to the meter.run and create your project. I have my own right here, and I open the web console. Okay, so before we start with the actual code, let's prepare our environment. The first thing you need to do is to connect the Cardano node, so you can go to the extensions, catalog. Here you have many, you have to choose Cardano node, and here you see shared instances in each of the typical networks we will be using preview. So you toggle, it connects, and now you should see your Cardano node available in your project. Next step is to set up a workload. We create a new one. You can have several things. In this case, we are just interested in having a development workspace. Now, to set up our workspace, we first need to specify where we're going to be pulling the code from. We have our tutorial here. We just copy the clone URL and we paste it right here. Now, regarding toolchain, we will be using Aiken, and we will be needing the Cardano CLI and Jupyter notebooks. We can use a small workspace, and we'll connect to the preview network because that's where we have our Cardano node extension connected to. Just hit create. And now we have to wait until the provisioning finishes. Okay, we're ready to go. So we open the VS Code IDE. First thing we need to do is to make some changes to our Aiken code. The source code for the validator is in the validators folder in the hello world.ak file. Let's open that. And we have this very cool syntax highlighting, and we also have some checks coming from the language server. For example, if I mess this expression up, we have Aiken complaining about it and explaining what we need to do to fix it. This is all thanks to the VS Code extension for Aiken language that we have already installed in this workspace. Now, back to our source code. Now that I have made some changes, just change the expected hard-coded message in the redeemer. We can go back, let's save this. We can go back to the tutorial and move to the next step. The next step is about turning our Aiken code into uPLC. For that, we need to run first the Aiken check command, and this will show us if we have any syntax errors or any warnings, and we'll also execute the tests inside, which we don't have for this very basic validator. Next, we need to build. For that, we run the Aiken build code that will generate a Plutus JSON file with the blueprint specification of our code. Now that we have our blueprint file, we can open it if we want to. Here's the full stuff inside it. Here we have our compiled code, but we also have the definition of the datum and redeemer so that we know what the validator is expecting. Okay, back to our tutorial. Next step, since we're using the Cardano CLI as our mechanism to build the transactions and submit them on chain, we need to turn the blueprint Plutus JSON file into the format that the Cardano CLI is expecting for scripts. Luckily, the Aiken CLI already has a command for that, which is blueprint convert, and we output the result of that conversion to a script JSON file. And we get this, which is what the Cardano CLI is expecting when building transactions. Okay. Last in this part of the tutorial is to generate our address for the script. Aiken has its own command for that, Aiken address. We ran that, and here we see the resulting address that describes our custom validator. Next step. Now that we have our script, we're going to be locking some test data in our script. For that, we need our own wallet. We will be using the Cardano CLI to generate our key pairs. If we run this, you will see that we get our secret key and our verification key in these files. Please don't commit these files in Git. They are ignored by default. Make sure that you don't push that anywhere public. Now, here we have the address, also generated by the Cardano CLI, and the key hash of our wallet address. And we're storing those values in these variables because we need to use them later on. Now, obviously, if we just created this wallet just now, we need to add some test data. So we're going to be copying the values here, and we're going to be using the testnet faucet. Here we just paste the address that we generated. We ensure that this is not ChatGPT, and we request fonts. Oops, I'm rate limited. That's bad. Okay, I will just transfer some test data from an old wallet. But if you're doing this for the first time, just repeat this process, and instead of being rate limited, you will just get some funds in your wallet. Back to our tutorial. Well, you couldn't see it on the recording, but I just switched my wallet for one that already has some test data, and this is the actual address that we will be using for the rest of the tutorial. And this is the key hash. Now, we need to query what we have on that wallet. For that, we can use the Cardano CLI to see which UTXOs we have, and we pass the address that we have stored in the variable in the previous step. And this will save the state of the wallet into this wallet.state file, and this is the contents. We have one item for each of the UTXOs that it holds. And here it's our test data. Next, we need to decide which input we will be using for our locking transaction, and we will just pick the first one. This is querying the previous wallet state file and using the first key and storing that on our input UTXO variable. This is the output, and this is what we will be using on a later step. Next, we need to build the datum. If you remember the logic for our custom validator, we need to be passing the owner of the assets. And for that, we build this special JSON that has the format that the Cardano client is expecting for our datum, and we are injecting the key hash of the wallet. If we run this, we get this value. This is our key hash, and everything is here in this datum.json file. Next, we're ready to actually build the transaction. Here you can notice that we are using the input UTXO that we selected from our UTXO set in our wallet. We are passing the script address that was generated using the Aiken CLI, and we're sending 10 test data, and we are adding the datum JSON content as an inline datum to the transaction, and everything that needs to be returned will go back to our wallet, and the output will be saved in this log.txt file. If we run this, we get to see the summary of the transaction built by the Cardano client. Here you can see that the input is the one that we specified, and that the output is going to our script address with 10 ADA, and it has our datum inside. Okay, cool. Now that we have our transaction, we need to sign it and to submit it. If we run this, we see that the transaction submission process succeeded, and we can now query the state of the script, and it should have, at some point when the chain actually receives the transaction, we should see the new UTXO that we just locked in our script. Let's try to refresh for a few seconds until it hits the chain. Nothing yet. Nothing yet. Nothing yet. Nope. And here we go. This is the state of our script address, and we see that we have the UTXO that we sent from our personal wallet, and we have the datum and the 10 test data. Cool. Now that we have locked some assets, now we will try to unlock those assets, and this is where the fun actually happens, because our custom validator will be executed for the first time. Now, first step is to decide which UTXO we want to unlock, and for that we will be selecting just the first one in our script address. Since this is a script address we just generated, we shouldn't have anything else, but in either case we are going to be picking the first one. Now, next step is to build our redeemer. On a previous step, we decided to change the hard-coded message. So this is not what the actual validator is expecting. So if we were to submit a redeemer with this content, the validator will fail. Since we don't want that for this tutorial, we will be copying the exact same hard-coded message from the validator into our variable so that we use it in the redeemer. If we run this cell, we will get the JSON representation of the redeemer in the format that the Cardano client is expecting it. Now, we need to select the lateral UTXO, and that should come from our wallet. For that, we query again the state of our wallet. We should see that we have a different set of UTXOs because we just locked something. And we will be using the first one. And our UTXO selected will be stored in the collateral UTXO variable. Now, we need also the protocol parameters since we're going to be executing custom Plutus script. We need to calculate the fee for that. So we use the Cardano CLI to download the parameters and store them in the params.json file. Next step is to actually build our unlocking transaction. Now, once again, we will be using the Cardano CLI for that. And notice that we are requiring our wallet to be signing the transaction. That's because our validator needs our signature as part of the validation process. We are passing also the parameters, the protocol parameters stored in this JSON file, and also important, we are adding our redeemer from the redeemer JSON. And we are telling the Cardano CLI that it should expect a datum present in the input UTXO. Okay, we run this, we get the output of the transaction in this unlock transaction file. And here we see that we have our collateral, we have the input that we want to unlock from the locked assets in the script, and we are sending that to our wallet, and we have the required signer, which is our wallet. Okay, yes, it looks good. Now we can sign that and submit it. Let's see what happens. Transaction was sent. Okay, now we just need to see if we actually got our assets back. Nothing yet, because this is what we already had in the wallet. So what we are actually expecting is a new UTXO, which should have our unlocked test data. So we just keep refreshing, waiting until the transaction hits the chain. Instead of seeing 2 keys here in this JSON file, we should be seeing 3. We just hit refresh until something happens. Nothing yet. This might get cut off from the video. And yes, here we go. Now we have our UTXO in the set. And the script address should now be empty. Yes, because we removed what we locked previously. Okay, cool. So to sum up, we just change our Aiken code. We build the anti-Pluto score that we need to submit on change. We submitted a transaction that locked some assets, and then we submitted a transaction that unlocked those assets, and our custom validator just executed and passed.